recall that the equation representing a quadratic relation in standard form is y equals ax squared plus bx plus c, where a, b, and c are all values, actual numbers. Really, a cannot be 0, or else we would just have a line. So right now, we're going to complete the table of values and identify key features, and then graph it based on this example. I've chosen the x values for you. We're going to figure out which y's correspond. So really what I'm doing is I'm subbing in -1 everywhere I see an x value. -1 squared is +1 times 2 is 2. -4 times -1 is +4 plus 1. We add all those together and we have 7. That substitution is what we're doing for each one of these points. If I do that in my head, I could fill the rest, or if I have a scrap piece of paper. Now one thing you might already notice is, and remember, that y-intercept. When x is 0, y is 1. Or when I sub in 0 squared is 0 times 2 is 0, minus 4 times 0, which is 0, 0 plus 0 is 0, plus 1 is 1. As I continue the rest, I start to see the rest of my graph, and I can now graph that. Now, our vertex is going to be that point where the things change. Now, if I remember and I look at my first differences, from 7 to 1, it went down 6. From 1 to -1, it went down 2. From -1 to 1, it goes up 2. From 1 to 7, it goes up 6. Our first differences, again, they're all different. We're not dealing with a line. Well, that's good to know. If I continue and look at my second differences, -6 to -2, it goes up 4. -2 to +2, it goes up 4. 2 to 6, it goes up 4. My second differences are all the same. I'm dealing with a quadratic, which shape makes a parabola. So if I look, I want to see the pattern. Where do things start to change? Where is that reflection point? And it's right there. That is my vertex. So my vertex is the point 1, -1. The direction of opening, if I think a cup opens up or the parabola opens down again, when I draw it, I might draw it first to C, but it opens up. If A, another way we might do that is if A is a positive number. So if A is a positive number, remember it opens up. A is a positive number, it opens up. My second difference is positive, it opens up. So there's two different ways I can see, or when I graph it. The y-intercept, I've seen that point, y equals 1. Is it increasing or decreasing? So remember that decreasing, if it opens up, we have decreasing and then increasing. So it's decreasing and then increasing past a certain point, past that vertex point. So without even graphing it, I know that it's decreasing when my x value is to the left of 1. So when x is less than 1, it's decreasing. It's going downhill from left to right. At the vertex, it is completely flat. And then when x is larger than 1 or past that point, it's going uphill. So all that information I can get from my table of values based on my equation. Now, if I plot that point, I'm going to have my vertex, or I just plot these points, -1, 7, 0, 1, my y-intercept, 1, -1, my vertex, 2, 1, and then 3, 7, and it goes back up. So remember, drawing parabolas, they're not u's, where the sides go straight up. They're not B's, and they're not U's that circle back on them. Those are all bad drawing skills. We're going to take practice, and we're going to get nice curves that continue to open up with arrows on them on the end to say that they continue. And that is one great looking parabola. Cool, cool, cool. All right, let's investigate. What happens if it's in a different form? What happened? Remember, we still have really an A value. The A's in front. It's like a number 1. So right now, without even filling this up, I know it's going to open up. Y-intercept, vertex, increasing, decreasing, I'm not sure. But if it opens up, then it's going to be decreasing, then increasing. So I'm going to put that order just so I remember. Decreasing and then increasing. Now, I'm going to still do the same thing. I'm going to substitute in what is y worth when x is -1. -1 take away 1 is -2. -1 take away 3 more is -4. -2 times -4 is +8. So I'm going to continue along this way. I'm going to sub in and solve. I'm going to do it in my head, / I've already done it ahead of time so that I know. And I start to see that pattern emerge. If I follow the same thing like I did before, from 8 to 3, it goes down 5, down 3, down 1, up 1, up 3, and that reflection point right there, that's my vertex. To -1. I'm going to put that on while I remember. Now the other thing that shows up here are the x-intercepts. Where does this line cross the x-axis? So the x-intercepts, as I graph them, are 3, 0, and 1, 0. Then I have my y-intercept, 0, 3, and the rest of my points. -1, 8. And following the pattern, I would probably assume that the next point is going to be 5, 8. I'm going to put that on and see, oh, it looks like it follows that. If we check, we follow this pattern, we can see that this goes up 2, up 2, up 2, up 2, which means 3 plus 2 is going to be 5. So from 3, I'm going to need to add 5. 3 plus 5 is 8. This pattern is all going up by 1. My first difference is 5, 8. It fits the pattern. I've also noticed my y-intercept that y equals 3, or just remember that's still a point, 0, 3 for my y-intercept. So from there, I can draw my parabola. Again, we said 5 points, but here's 7 because I have the space on the graph. The more points that I can draw, the more accurately I can draw my curve. Okay, so what other features can we find from this graph? Well, we see an axis of symmetry, which in this case, x equals 2. Well, there it is. It's the x value of the vertex. Because it opens up, remember it has a minimum, there's an actual bottom. It goes up forever, but there's an actual bottom, a minimum of -1. That's all from the vertex. You should also see that somehow we saw the x-intercepts. We can see them clearly on this graph, whereas the other one above, the first example, they weren't clear. So the x-intercepts, we have x equals 1 and x equals 3. Now how do 1 and 3 connect with our original equation? Well, in this form, called factored form, kind of like the title, those are our x-intercepts. There's 1 and there's 3. So right away, we can see our x-intercepts. Now the default equation has a negative in it, so there it is. So what does that tell us? And hopefully this shows up in pink. It tells us our x-intercepts. The way to think about it is they are the opposite of the numbers in the brackets. That might be our clue, but really what it is, it's what value of x would make each bracket equal to 0. So an x-intercept of 1, 1 take away 1 is 0. An x-intercept of 3, 3 take away 3 is 0. There's my second x-intercept. Okay? So let's see if we can do the last example or flip the page. We'll do that right now. So using all the information we have, let's see if we can do this. We have an a value, -2. That's going to tell me that it opens down. We have x-intercepts of -1 and -3 in the brackets, so it's +3. So an x-intercept of -1 and +3. So when x is -1, y is 0. When x is 3, y is 0. Because it opens down, it's going to increase first and then decrease from the vertex. And so if I look, the middle, there's my vertex right here. I don't know the value yet, but I know the x value of 1, so it's going to decrease, or it's going to increase when x is less than 1 or on the left of 1, and it's going to decrease, go back downhill when x is greater than 1 or to the right of 1. Okay? As I now fill in the rest, I'm going to sub in when x is -2, do the math, and I have -10. I have when x is 0, I'm going to have 6. And then I could follow a pattern to fill out the rest. Let's see. That went up 10. This went up 6. If I filled in that vertex, when I sub in 1, I'm going to get 8. Goes up 2. If I look at this, my second difference is in this color. We go down 4, down 4. So if I follow that pattern, down 4, 2, take away 4 is going to be -2. Take away 4 is going to be -6. Take away 4 is going to be -10. So even though I have done some of the math, I'm following the pattern. 8 take away 2 is 6. 6 take away 6 is 0. 0 take away 10, -10. I've got my vertex. I can put that in. 1, 8. Got my y-intercept of 6. And then I can graph the rest of the points. 0, 6. 1, 8. 2, 6. 3, 0, 4, -10. And -2, -10. As we can see, it opens down. I practice drawing my parabola, a nice curve that opens, smooth, arrows on the end to show that it continues. Okay, let's look down below.